Imagine the universe in its infancy. It was a turbulent, fiery place, long before the first stars flickered into existence. In this primordial chaos, something invisible was already taking shape. Scientists have uncovered evidence of vast, universe-spanning magnetic fields that existed a mere 370,000 years after the Big Bang. This is a profound mystery. Where did they come from? There were no stars, no galaxies, no black holes, none of the usual cosmic engines we associate with generating such powerful forces. It's like finding a fully formed spider web in a house that hasn't even been built yet. These fields were just there, permeating the cosmos with a faint, ghostly hum that we are only now beginning to detect. This discovery challenges our fundamental understanding of cosmic evolution. We thought we had a pretty good timeline for how things developed. The Big Bang, the cooling period, the formation of atoms, and then, much later, the gravitational clumping that led to stars and galaxies. But the presence of these ancient magnetic fields throws a wrench into that neat sequence. It suggests that magnetism might be a more elemental and primordial force than we ever imagined. It wasn't something created by cosmic structures. It was a feature of the universe itself, present from almost the very beginning. It's a cosmic riddle that pushes the boundaries of our knowledge and forces us to look back to the dawn of time with fresh eyes. Here's where things get really interesting. When scientists measured the strength of these primordial magnetic fields, they found something astonishing. Their strength was about 1/1,000,000th that of a compass needle's magnetic field here on Earth. That might sound incredibly weak, almost insignificant. But let's put it in perspective. This faint cosmic magnetism is remarkably similar in strength to the magnetic fields generated by the human brain. Yes, the very same fields produced by the electrical currents firing between your neurons as you think, feel, and read these words. It's a fascinating and almost poetic parallel that bridges the gap between the vastness of the cosmos and the intimacy of our own consciousness. This comparison isn't just a quirky coincidence. It offers a tangible way to grasp the subtle power of these ancient fields. Your brain's magnetic field is incredibly delicate, requiring highly sensitive instruments to detect it. Yet it is the product of the most complex structure we know of, the human mind. The idea that the entire early universe was permeated by a magnetic field of similar strength is mind-boggling. It paints a picture of a cosmos that wasn't just a chaotic soup of particles, but a place with an underlying ordered structure, humming with a faint magnetic energy. It's as if the universe itself was engaged in a slow, silent form of thought. Of course, we aren't suggesting the universe was literally thinking, but the analogy helps us appreciate the nature of this force. It was a subtle influence, not a violent one. It wouldn't have ripped matter apart, but it could have gently guided the flow of charged particles over vast stretches of time and space. Much like the faint electrical signals in our brains orchestrate our thoughts and actions, these weak magnetic fields could have been the unseen conductors of the early cosmic symphony. So, when and how did these magnetic fields come into being? The evidence points to a specific period in cosmic history known as the recombination era. This occurred about 370,000 years after the Big Bang. Before this time, the universe was an opaque, superheated plasma, a roiling sea of protons, electrons, photons. The photons, or particles of light, were constantly scattering off the free-floating electrons, unable to travel far. The universe was like a dense fog. During recombination, the universe cooled down enough for protons and electrons to combine and form the first neutral hydrogen atoms. Suddenly, the fog lifted. It was in the final moments of this plasma state that these magnetic fields seem to have been generated. One leading theory suggests that tiny fluctuations in density and temperature in the primordial plasma created a phenomenon called the Biermann battery effect. Think of it like this. In the swirling cosmic soup, the lighter electrons were pushed around by photons more easily than the heavier protons. This slight separation of charges created tiny, localized electrical currents. And as we know from high school physics, any moving electrical current generates a magnetic field. It was a small effect, but repeated over and over across the entire universe. These tiny magnetic seeds, once planted, could have then been amplified. This process, known as a dynamo effect, could have dramatically strengthened the fields. To truly appreciate this discovery, let's take a step back. What exactly is a magnetic field? You can't see it or touch it, but you've seen its effects. It's the invisible force that makes a compass needle point north. It's the invisible force that holds a magnet to your refrigerator door. It's the invisible force that allows electric motors to spin. At its most fundamental level, a magnetic field is a force field created by moving electric charges. On Earth, our planet's molten iron core swirls and flows, creating a massive electrical current. That current generates the magnetosphere, the protective magnetic bubble that shields us from harmful solar radiation. Without it, life on Earth would likely be impossible. In space, magnetic fields are cosmic superstars. They guide the flow of the solar wind. They are responsible for the beautiful, shimmering auroras on Earth and other planets. They corral hot plasma within stars, helping to sustain nuclear fusion. When massive stars explode as supernovae, their powerful magnetic fields help accelerate cosmic rays to nearly the speed of light. They are the unseen hands that shape and direct matter throughout the cosmos. Magnetic fields act as a sort of cosmic traffic cop for charged particles. A charged particle, like a proton, can't easily cross a magnetic field line. A charged particle, like an electron, can't easily cross a magnetic field line. Instead, it is forced to spiral along it. This means magnetic fields can create channels, walls, and structures out of what would otherwise be a chaotic mess of plasma. They can influence where and how stars form by directing the flow of interstellar gas clouds. They can shape the magnificent jets of energy that blast out from the regions around supermassive black holes, stretching for thousands of light years. In short, to understand the universe, you have to understand its magnetism. So these magnetic fields existed billions of years ago. But did they just fade away? The evidence suggests no. Scientists believe these ancient fields still exist today, woven into the very fabric of the cosmic web. The cosmic web is the largest known structure in the universe. It's a vast, intricate network of filaments, clusters of galaxies, separated by immense dark voids. Gravity shaped this web, pulling matter along invisible threads of dark matter. But the primordial magnetic fields may have provided the initial scaffolding, leaving their imprint on this grand design. They have been stretched and diluted by the expansion of the universe. But they haven't disappeared. Astronomers have found tantalizing clues that support this idea by studying the faint radio signals coming from the vast, empty spaces between galaxies, the cosmic voids. They have detected the presence of incredibly weak but enormous magnetic fields. These fields are far too large and uniform to have been created by any individual galaxy or cluster. The most logical explanation: direct descendants of primordial fields from the recombination era. They are the echoes of the universe's first magnetic hum, still resonating 13.8 billion years later. We are finding the fossils of the universe's first magnetic skeleton. Detecting these fields is an incredible technical achievement. Scientists use powerful radio telescopes to look at distant sources of light, quasars. By measuring it carefully across many lines of sight, astronomers can map the strength and direction of these ghostly fields. Understanding these primordial magnetic fields is not just an academic exercise in cosmic archaeology. It has profound implications for our most fundamental models of the universe. For decades, our standard model of cosmology has focused primarily on gravity, dark matter, dark energy. It has been incredibly successful, but the discovery of early magnetism suggests there's a major player we've been underestimating. It forces us to add magnetism to the list of key ingredients that shape the universe from the very beginning. This could help solve some long-standing cosmological puzzles. One mystery: we observe fewer small dwarf galaxies than gravity-based simulations predict. Maybe early magnetic fields played a role. Magnetic pressure in gas clouds could have given an outward push, resisting gravitational collapse. That might have prevented some of the smallest galaxies from forming. Studying these fields gives a unique window into Big Bang physics. If fields were generated during the inflationary epoch, a period of hyper-fast expansion in the first fraction of a second, their properties could carry clues about that event. This era is far beyond what we can test on Earth. The universe becomes our particle accelerator. Ultimately, this quest completes our story of cosmic origins. How did a hot, dense, uniform state evolve into a rich, complex, structured universe? Ignoring primordial magnetism is like ignoring language or trade when telling human history. It's a fundamental part of the story. We began this journey by comparing the faint magnetic field of the early universe to the one generated by the human brain. The parallel is striking: a field with the strength of a thought, permeating everything, a force that gently, subtly, and patiently guided the formation of the first structures over millions of years. This wasn't the brute force of gravity, crushing matter into stars. This was something more akin to a whisper, an organizational principle that nudged the cosmos toward complexity and structure. It's a profound and beautiful image, suggesting an inherent orderliness to the universe from its earliest moments. This discovery blurs the line between the seemingly inert physical world and the complex, organized systems we associate with life and consciousness. While the universe isn't a literal brain, the fact that similar physical principles operate at such vastly different scales is awe-inspiring. It suggests that the capacity for complex organization is baked into the laws of physics themselves. The same electromagnetic force that allows neurons to communicate and form a thought also wove a magnetic tapestry across the infant cosmos, a tapestry that would become the framework for galaxies. And so we are left with a tantalizing thought. If the faint magnetic hum of our own brain activity is the physical manifestation of our consciousness, what are we to make of a universe that was born with a similar hum?